Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to classify triangles by sides and angles. Don't forget there are practice problems at the end of this presentation for you to try out in order to demonstrate mastery of the contents of this presentation. Tons of support resources can be found at Mathgotserved.com to check it out, and also take a look at the links in the description below to gain access to the entire course and other materials to help you study geometry. All right, to get us started, we're going to take a look at some vocabulary terms to help us classify triangles by sides and angles, and then we'll look at some examples after that. Okay, so first of all, we're going to take a look at classification by sides. All right, so the first classification by sides that we have is the equilateral triangle. Equilateral. Think about equi as equilateral as side measures. So equilateral triangle is the first classification by side. Okay, so equilateral triangles, what is an equilateral triangle? This is a situation where all side measures are equal. Okay, all side measures are equal. So let's take a look at a visual representation of what equilateral triangles are. So you basically have, it's just a rough sketch. A triangular situation where all the sides are equal. How do you mark it? How do you show that it's an equilateral triangle? Just mark all three sides with the same number of tick marks. Okay? So if you have something like this, that shows that you have one tick for each side. This shows that we have an equilateral triangle. Okay, so let's say this is ABC. This is an equilateral triangle because AB, the length of AB is equal to the length of BC, and that is also equal to the length of CA. All right, let's take a look at an example of an equilateral triangle. All right, so what values can we put on the three sides to show that this is an equilateral triangle? Let's mark it first. So let's say we have 3. If this side is 3 and this is an equilateral triangle, guess what? This side will be 3 and this side will be 3. So this triangle is an equilateral triangle because the measures of all three sides are equal. All right, the second classification by sides is isosceles. Isosceles triangle. All right, how does this work? Well, for isosceles triangle, you have a situation where only two sides, only one pair, only two sides, only two side measures are equal. Okay, so if you have only two side measures are equal, then you have an isosceles triangle. Only two side measures are equal. So for equilateral, all three side measures are equal. For isosceles, only two side measures are equal. All right, so how do we mark an equilateral triangle? An isosceles, so equilateral marked all three sides, right, indicating that all three sides are equal measures. If we have only two sides that are of equal measures, we just only mark only two sides, the two sides that have equal measures. So this triangle right here, triangle ABC, is an isosceles triangle. Why is that? It's an isosceles triangle because side AB is equal to BC. You have only one pair, or only two sides are congruent or have the same measure. Let's take a look at an example. So what side measures will make this an isosceles triangle? Let's mark it first so we know that this side is congruent to that side. It's obvious. So let's say this is 7. Guess what? This side also has to be 7 in order for it to be isosceles, and this third side has to have a measure that's not equal to these two. So let's say it's like 3 units. So this triangle right here is an example of an isosceles triangle because you have only two sides with equal measures. All right, the last classification by side measures is known as the scalene triangle. Okay, so what makes a triangle a scalene triangle? You have a scalene triangle when no side measures of a triangle are equal. Okay, so no side measures are equal. So let's take a look at a visualization of a scaling triangle. This is a scaling triangle right here. Why is it a scaling triangle? Well, this triangle right here, let's call it triangle ABC. Triangle ABC is a scaling triangle because AC is not equal to AB and is not equal to CB. So no pair of sides are congruent. Okay, that's what a scaling triangle is. So let's take a look at an example of a scaling triangle. What side measures do you think we can put in here to reflect that this triangle is scaling? Well, let's say this side measures 2. This cannot be 2. So this side will be, let's say 3. And then this side cannot be 2 or 3. So let's say 5. So this triangle is a scaling triangle because no side measures are equal. Alright, so next we're going to be taking a look at classification by angles. Alright, so we took a look at classification by sides. Now let's see how can we classify a triangle based on the angle measures. So the first one we're going to look at is an acute triangle. Alright, we know what acute angles are, right? So we're just going to extend that definition to a triangular situation. So what is an acute triangle? You have an acute triangle when all angle measures are less than what? Are less than 90 degrees. Okay, all the angle measures of the triangle are less than 90 degrees. Alright, so this is an example of an acute triangle. Well, why is that? Because if you take a look at the angles, you can see that none of them are 90 degrees or greater. They're all less than 90 degrees. Okay, so angle A, angle B, and angle C measure less than what? Less than 90 degrees. So basically, we're going to be taking a look at the comparison of the angles relative to 90 degrees in a lot of cases to determine the classification based on angles. Alright, let's take a look at an example. Alright, so what angle measures will make this triangle an acute triangle? Remember, when we're populating the angles, it has to satisfy the triangle angle sum theorem, namely the sum of angles have to add up to 180. So let's say this is 70 degrees. That's good because it's less than 90. And then let's say this is 50 degrees. That's also good because it's less than 90. If we add these two together, we get 120. And this has to be 60 degrees. That's also good because it's less than 90 degrees. Okay, so this is an example of an acute triangle because all the angle measures are less than 90 degrees. The next one is known as equiangular triangle. Okay, equiangular, if you just take a look at the name and you break it into parts, you can tell what it means. Equiangular, equi means equal, angular means angles. All right, so what's the situation here? You have an equiangular triangle when all the angle measures are the same. Okay, so equiangular triangle, this is what you have when all the angle measures are the same. And guess what? Whenever you have an equiangular triangle and all the angles are the same, they're also equal to 60 degrees. Okay, all the angle measures are the same and are 60 degrees each. So each angle measure is 60 degrees. Why is that? Because the sum of the angles in the triangle is 180 degrees, and if you split that into 3 even parts, you get 60 degrees for each one. Okay, so how do we mark a equiangular triangle? Just mark all the angles are the same, like this, with the same number of arcs. So one arc for all the angles show that they're all the same measure. So this triangle ABC right here is an equiangular triangle. So it's equiangular because angle A is congruent to angle B and is congruent to angle C. Okay, so let's take a look at an example. What does an equiangular triangle actually look like? What are the measures of the angle? Well, they're all the same and it must be 60 degrees. So we'll have a 60, 60, 60 triangle. That's an equiangular triangle. Okay, so something to note is that all equiangular triangles are acute. All right, all equiangular triangles are acute. So basically, equiangular triangles is a special case of acute triangles. All right, so the next classification that we have by angles are right triangles. Okay, so what is a right triangle? Well, if you know what the definition of right angles are, you are in good shape. All right, so right triangle. What is a right triangle? Is a triangle where one angle does what? One angle measures 90 degrees. Okay, so let's go ahead and draw what it looks like. How do we mark a right triangle? See, so just draw a triangle and then just mark one of the angles as 90 degrees. How do you reflect that? Just put it like that. That's how you mark a right triangle. Okay, so let's take a look at an example of what a right triangle is. So what angle measures can we put here to make this a right triangle? Well, one of the angles has to be 90 degrees, okay? And then the other combination should be 92. So let's say this is 30 and that's 60. So this right here is a right triangle because one of the angle measures 90 degrees, namely this one right here. Okay, the last classification of triangles based on angle measures is the obtuse triangle. Okay, so what is an obtuse triangle? We will know what obtuse angles are, right? Obtuse angles are bigger than 90 degrees, okay, and less than 180. So that applies here too. So an obtuse triangle is a situation where one angle measures greater than 90 degrees, okay? Or over. One angle measures greater than 90 degrees. So let's make a sketch of what it looks like. All right, so what makes this triangle right here an obtuse triangle? So let's say this is ABC. Okay, let's backtrack a little bit. So number 3, we were supposed to say that the measure of angle C is 90 degrees. Say this is C and this is A and B. All right, so for this one right here, what makes this an obtuse triangle? The measure of angle C in this case is greater than what? Is greater than 90 degrees. That automatically makes it an obtuse triangle. Okay, so let's take a look at a concrete example. What angle measures can we input into this triangle right here to make it an obtuse triangle? So one of the angles has to be greater than greater than 90, right? So let's say this one right here is 120 degrees. All right, so that's greater than 90. That automatically makes it an obtuse triangle. So let's say this one right here is 20 degrees. So we have 140, so it's 40 degrees left to make it, to satisfy the triangle angle sum theorem of the sum of angles being 180. Okay, so this is an example of an obtuse triangle because one of the angles is greater than 90. All right, so let's take a look at some examples. Instructions for these examples are for us to classify the given triangles. We're going to classify them by their sides and angle. All right, so for question number 1, let's say we have 74 degrees, 58, 48, and then this side, 48 degrees, this side measures 5.6, 4.9, and 4.3. All right, so how can we name this triangle based on the sides and angle? All right, so here are the steps that we're going to follow to solve this problem. Let's put the steps right here. So first of all, we're going to mark the triangle if applicable, because some triangles don't have any marks in them. So you mark the triangle. 2, you classify by name by or classify by angle. And then 3rd, you name by side. So let's take a look at triangle in number 1. Okay, so if you look at the side measures, all the side measures are different. So we don't have to mark them because those two pairs are congruent. All the angles are different in measures. So let's nothing to mark here. So if we want to name it by angle, what do we notice concerning that by angle? All the angles are less than 90. So all angles are less than 90 degrees. Bam. So what does that tell us? Since all the angles are less than 90 degrees, it's going to be an acute situation. How about sides? What do we notice about the sides here? They are all different. All different measures. All right, since all the sides are different measures, what is it? It's scaling. All right, so this is an acute scaling triangle. All right, let's take a look at number 2. So for number 2, let's say this is 90 degrees, and then this is 45, and this is 45, and this is 4.8, and this is 4.8, and this right here is 6.8. Okay, so can we mark anything here? Yes, this is 90 degrees, so we can put that right angle mark there for the angle. Now for sides, these two sides are congruent, so we can mark it that way. Okay, so now we're done marking. Let's name it based on angles. So what do we have about in the angle situation? One is 90 degrees. Okay, so what does that tell us? That tells us that this triangle is right. Naming by angle. Okay, and if we want to name it by sides, what do we notice about the sides? It has one congruent pair. All right, these two sides are equal. If you have one congruent pair, that means it's isosceles. Isosceles. Bam. So this is a right isosceles triangle. All right, next one, number 3. Let's say that this is 60 degrees, and this is 60 degrees, and this is 60 degrees, and then this is 7, 7, 7. All right, so let's start off with this one, number 3. We're going to mark it first. Angles. We notice that all 3 angles are the same. Bam, bam, bam. Okay. And then the sides, all 3 sides are the same too. So let's make some notes here. Naming by angle. All angles are congruent, right? All angles are congruent. So what does that mean? It means it's an equiangular case. Naming by sides. What do we have here? All sides are what? All sides are congruent too. So what do we call that? What do we call a triangle where all the sides are congruent? It's called equilateral. Okay, So there you have it. You can also call it an acute equilateral. It's the same thing. Or just equilateral triangle, because all equilateral triangles are acute and all equilateral triangles are equiangular. So just calling it equilateral, angular equilateral, or acute equilateral, that will all suffice. Okay? So let's write down all the possible names that you can call this. You can call this angular equilateral, or you could call it acute equilateral, or you could just call it an equilateral triangle. That's sufficient. All right. Okay, last one before you try out some practice problems. Number 4. Let's say this is 116 degrees and this is 32 and this is 30. 32. Just made a slight change to the drawing, so it's 32, and then this is 2.7, 2.7, and 4.5. All right, so how do you name this triangle? So let's mark it first. So if we want to mark it, we just know that this angle right here, these two are the same. Well, this angle right here is, this one is greater than what? Greater than 90 degrees. And then we have these two sides are the same. Okay? So for angles, we know that one is greater than 90 degrees. And then for sides, what do we know? We have one congruent pair. One congruent pair. Okay? So if one angle is greater than 90 degrees, it's called an obtuse triangle. And if you have one pair of congruent sides, okay, just two sides that are the same, it's called isosceles. So this triangle is called an obtuse isosceles triangle. Okay. Alrighty, so here are some problems that we would like you to try out. So we'd like you to try these problems out. Instructions are the same as before. So you have to classify the given triangles by their angles and sides. Okay. So go ahead and pause the video presentation and solve this. When you're done, click on the playback button and we'll show you what the answers are. All right, welcome back. So hopefully you had a chance to try out the given problems. Let's take a look at the answers to these questions. So the first one is an acute isosceles triangle. So this is acute isosceles triangle, and if that's the case, we have these two sides right here that are congruent and all the angles are less than 90 degrees. For number 2 is an obtuse scaling triangle because one angle is greater than 90, this one right here, and all the side measures are different. Number 3 is a right isosceles triangle because these two sides are congruent. You have one pair of congruent sides and a 90-degree angle measure. Okay, so it's 90 degrees right here. And then number 4, this one right here is an equiangular equilateral triangle because all the angles are the same, 60, 60, 60. Equiangular, and all the sides are the same, 5, 5, 5, equilateral. So it's an equiangular equilateral triangle. Okay, let's put triangle here and triangle here. So there you have it.